Welcome to the project demonstration of energy meter based load calculation with minimum, maximum and average displaying on 16:2 LCD screen. So here we are going to calculate the load if we run that particular load for 10 minutes or 1 hour or half an hour in the duration. So the system will calculate the how much of load consumed by the particular load, like minimum value and maximum value, and also till the duration what is the average load. So that will be displayed on this LCD in terms of kilowatts. Okay, and it will be calculated by our PIC 16F73 microcontroller. So the load we are going to connecting at this section, and the wattage of the load will be calculated from this energy meter through this LED. So this LED will blinks whenever the load is connected, and the blinking rate will define the load wattage, and that blinking rate will be calculated by our PIC microcontroller through this optocoupler. Why? Because even though we are using LED, so if is there any power fluctuations occurred, so then if we connect that particular LED directly to the microcontroller, so this will damage the microcontroller. So in order to protect the microcontroller, we place the optically coupled. So inside this optically coupled isolator, this optocoupler. So here we have this side we have the 2 pins, and other side the 2 pins. So the input side is the 2 pins are connected to the LED inside this optocoupler, and output of this given to the photodiode. So that photodiode will provide the same pulses which we get from the LED. So here the optocoupler number is PC817, and that pin is given to the output from this optocoupler given to the A4 pin of our PIC 16F73 microcontroller, and the main output module is LCD is connected B2 to B7, and one more LED indication HC4 pin. And coming to this motherboard, so we have the crystal oscillator, the steel plated one, 20 MHz oscillating frequency, so which will provide the clock pulse of 20 MHz. So the purpose of this crystal oscillator is we have provided one set of instructions inside the microcontroller. So for every instructions it need a clock pulse. So when the clock pulse enter into the microcontroller, it will execute one instruction. So like that, the so-called set of instructions continuously executed whenever it get the continuously clock pulse. And the next, so there will be a one capacitor just to provide the constant power supply whenever the power fluctuations occurred. And here this is the reset switch in order to provide the restarting feature to the microcontroller. So next, so here we are going to calculate the minimum, maximum, average for these two loads, was 100 watts and another is 200 watts. So here the calculation part is whenever the light is blinking continuously, so whenever it's blinking, the blinking rate goes up to 12 blinks, then it's indicated as 1000 watts load is connected. So let us see the demonstration. So we'll place the 100 watts bulb initially. Right, we need to provide the power supply to the system also. That will be provided from this adapter. The adapter will take the 2 volts input and it will provide the 5 volts output. So we need to connect the power supply section for the microcontroller. So now the system will calculate the now the load, minimum, maximum, average, and so average load, and the below the minimum and the maximum. So this is in terms of kilowatts. So when we multiply this with 1000, we will get the wattage. So based on the load, it will take the time. So if we connect the lower load, it will take around of 10 to 15 seconds. If we take the higher load, it will calculate it within 4 to 5 seconds. Now we can see that. So we have placed so the fixed load 100 watts. So that's why displaying the average load is 0.11 kilowatts, and minimum is maximum. Both are same because it's not a variable load, it's a fixed load. So let us connect the another load as we are changing the load now. So now we are connecting the 200 watts bulb. Now let us wait for the calculation part. So the minimum load is 0.11 only because we have connected the maximum load again. Right, now the maximum load is changed. So as the system is keep on running, the average load will increase because it adding the 200 watts to the previous reading. So right, the average load is increasing, and the maximum is 0.19. It's near to the 200 watts, and the minimum is fixed only 0.11. So if we restart this system, now it will calculate from starting onwards again. So now the minimum maximum average is going to be 200 watts only. Right. So now minimum maximum average, 3 readings are same. So now let us change it to the 100 watts bulb. Now let us decrease the load. And now minimum load comes down to 0.11 and maximum is same, but average will be increased near to the maximum load. Why? Because if we place the maximum load, the maximum duration, the average load and maximum load will come to the near to the same value.